Hi, everyone. We keep kind of learning new and better things with just how to do online math. One thing that I figured out today was how I can embed videos right into this program. So I think that's kind of nice because it's one less thing for you to have to go and check. It also allows me to make shorter videos and just kind of put them right in front of the problem that you're trying to do. The downside is I can't ask you questions within the video. So just a quick thing, if you're struggling with something, you're not sure how something works, shoot me an email, send a picture of your work or send a picture of the problem. All those things are helpful. I will try to get back to you as soon as I can. Sometimes that's within a couple minutes. Sometimes it might take me an hour or two, just depending on what's going on in my day. But I will respond to you eventually. Um, Before we get too far here, motivational poster from my wall. Backwards there. There we go. Today is the tomorrow you worried about yesterday. Very practical for what we're doing right now. A lot going on. Think of all the benefits of having to unplug a little bit. I know there's a lot of bad things going on in the world, but can you focus on some of the good things right now too? Phone caddy is back there yet? Put your phones away. Try to stay focused. Let's see what happens here. So I have a problem that's up here on the right side of your screen. I actually want to focus on the left side just as a bit of an introduction. We have looked at parabolas, quadratics quite a bit. But if we think about it, this green shape here could also be somewhat valuable. We don't look at it a whole lot yet this year. We might get to it at the very end of the year. We'll see. But that is that's a version of the square root function. It is the top part is the square root, and the bottom part is the negative square root. We typically just look at the positive version. But the idea here is that x squared and square roots, they undo each other. They are inverses of each other. And so if I were to plug something into x squared and got an answer, if I took that answer, plugged it into square root, it would just undo what I had already done. So think of plugging a 3 into x squared, you get 9. If you plug a 9 into square root, you get 3. They undo each other. So what we're doing is we are looking at, let's see if this works. There we go. Okay, we're looking at exponential functions. So the blue function there, that is exponential growth. We looked at the graph a while ago. That's not the point of this video. We're actually going to look at that again after spring break. But for the same reason that maybe knowing how to undo a parabola was important, we want to know how to undo a square root. So that's the focus of today, is to say, well, how do we undo an exponential growth sort of function? And the answer is something that's totally new. It's something called a logarithmic function, or we just use log for short. So the red function is kind of what the graph of the inverse would look like. So whatever I plugged into the blue function and got an answer, if I plugged that answer into the red function, it would give me what I had originally started with. The notation you can see is log base b of x. And that doesn't necessarily mean a whole lot other than we can know that the context is it's the inverse of exponential. So I know there's a lot of crazy things going on. I thought that this was kind of valuable just to try and make a connection to what we're doing. We're going to come back to this after spring break, but for the next couple of days, this is really the connection that you want to know in black here. Okay, I can go back and forth between these two versions. If I have y equals a number to the x power, so that's an exponential function, we just understand that the a value, the number that's in front of b, it's just going to be 1 for these kind of problems. Okay, but if I have y equals b to the x, I can rewrite that as a log function when I say log base b of y equals x. So they have the same base, b is still the base, but what's next to the base has switched. In the first one, x was next to it, and in the second one, y is next to it. And really the only thing that we're going to do today is we're going to start with, let me draw something here. Okay, we're going to kind of start with this, and we're going to have a missing piece, and in order to solve for that missing piece, we're simply just going to rewrite it in the form that's on the left and then try to solve for the missing variable. Okay, that's our goal. So if you haven't taken any notes yet, I don't necessarily think you have to take down the pictures that are at the top. If you think that's not going to confuse you too much, I would do that. But you definitely want to have what's in black written down. Okay, that's going to be very important for what we do today. And then just a couple of notes. In green there, when you see any sort of question that just has log of 7, there's no base there, it's understood that the base is 10. It's called a common log. So we might even want to jot that down. Okay, this is a common log. Okay, and if you see ln, that stands for natural log. Okay, and we just write that with having a log with a base of e. And e is kind of like pi. Pi is a very well-known number. E is another fairly well-known number, maybe not yet for you, but in higher levels of math, it has some unique properties. So e is approximately 2.71. So those are just kind of two things in green and in red, just some things to note that might pop up. Whenever you see that kind of notation, just realize that means, oh, my base was 10 or my base was E, and then you go from there. Okay, so from there, we are going to look at the question here that's on the screen. So we have something that's written as, let's see here, we'll just kind of make a new line here. We have log base 5x. Okay, and then we have a 5. And it's equaling 3/4. Okay, and the instructions are just take this and write it as an exponential function. Well, that means just take this rule that's in black here. We have the piece that is circled in red there, and we just want to rewrite it in the form that's on the left side. Write it as an exponential function. So keep in mind that whatever is next to the log, that kind of goes off by itself. The base stays the same. And circled in red there, whatever is off by itself becomes the power. Okay, so for this one, if I were to kind of compare the two, okay, 5x is the base. So I would have, let me get my pen back up here. Okay, 5x is the base. I'm going to raise it to the idea that's way far away. So I'm going to raise it to the 3/4 power. Okay, and it's going to equal the thing that was next to or in parentheses there that we're taking the log, so it's going to equal 5. So that is basically what they're asking you to enter in here. So we just want to practice doing this on our as far as inputting it, maybe using our keyboard just a little bit more. So let me slide this over just a bit so you can see it a little bit better. Okay, sometimes this keyboard option is important. Okay, so I'm going to have, let's see, we said 5x. And now we have to raise it to a power. So that's where this keyboard comes in handy. We want to raise it to a power, so I'm going to hit this button right here. Now, I personally think we should be able to write 0.75 because that is what 3/4 is equivalent to. So I want to see if it does that. Whoops, one thing I forgot. Okay, all of 5x is the base, so I really need to put that in parentheses. So go back and put that in parentheses. I think that could be kind of important. Okay, and then it's equals. Now I had to hit the arrow one more time so that it got away from the power and got back on the mean line, and that's going to equal 5. So I hope that that's going to take that as a good answer. We'll submit it. Yes, I'm sure. And it did take it. Okay, and then here's the solution. So if you get it wrong, you have to get really good at looking at the solution, figuring out what sorts of things you might need to change. So don't just go on to the next question. I think that's one thing that I've had to hint at a little bit with a number of you, that when you get something wrong, it doesn't mean you just go on to the next question. It means you have to take a little bit of time and compare your work to what's going on. I've talked a lot in different videos today. I can't remember if I said this at the very beginning, but one thing I'm going to change with this lesson is I'm going to limit how many questions you can actually try as far as what I'm going to look at when I grade. So if you happen to get one wrong, it's not the end of the world, but do take a little bit more time just to look at your work, try to make a correction to it, try again, and really learn from wherever you're seeing a little change in what you did to what this program is telling you to do. I do think, though, that you can do more than what I'm asking you to do if you want some more practice, but I'm just going to limit how many I want you to look at, because I think sometimes we're doing a little bit too much with that. Okay, email me if you have any questions, and we'll move on from here.